Hi, today we're going to talk about 9.1 section interpreting graphs. And this will hopefully be a short lesson, but it has taken forever to create because I was trying to create the bar graphs and stuff that I was seeing in the book in Excel, and it just was taking forever. So hopefully it will not take long to get through this. Hopefully you've seen bar graphs before. This is an example of a bar graph. You can have vertical bar graphs or horizontal bar graphs. These are called vertical bar graphs because the bars are vertical. These are horizontal bar graphs because the bars are horizontal. Not rocket science, right? All right. There is on page 418, there is a picture that has all of this stuff. So you can go there to study it, but this is the chart title. The major grid line is the darker line, and the minor grid lines are the fainter lines. Sometimes you have to do some math to calculate what that increment is for the major grid lines and the minor grid lines. For my graph here, it is 10. You can see with each major grid line that I get to, I'm incrementing by 10, so 10, 20, 30. But the minor grid lines are incremented. Let's see, there's 1, 2, 3, 4, 5. There's 5. So 10 divided by 5 is 2. Then you'd know that is each of these minor grid lines is a count of 2. In the book, the numbers and scales are different. The scale is different because I created this in Excel and I couldn't figure out how to change that scale. So in the book, the axis is vertical with the scale going on it, and it goes from 0 to 20, and it has 1, 2, 3, 4. There are 4 lines, 4 little minor lines, minor grid lines. So that means you'd go 20 divided by 4 and get 5. So each of those minor grid lines would be a count of 5. That's for in the book on page 418. All right. Example 9.1a says that it asks you to examine this bar graph and ask the question, which planet has the largest diameter? So bar graphs are great for just looking at the data and being able to quickly compare. Obviously, Jupiter is the largest. Now, which planets are less than 40,000 kilometers? You don't even have to you don't have to put any thought into it. Here is where 40,000 kilometers is. Here's where 40,000 kilometers is. And then we have Mars, Earth, Venus, and Mercury are the ones that are less than 40,000 kilometers. Notice the diameter is in 1,000 kilometers. I don't know why this keeps switching on me. Ah. Sorry guys, I have been working on this lesson for entirely too long. And now it's 6:30 and I need to go make dinner. So I'm rushing and making mistakes. Alright, so this is the diameter in 1,000 kilometers. So this 40 right there actually represents 40,000. So our answer here is Mars, Earth, Venus, and Mercury. And then what is the approximate diameter of the Earth? Well, you have to calculate what the minor grid line is. So we have 1, 2, 3, 4, 5. 520 divided by 5 will get 4. So each of these minor grid lines represents 4,000 kilometers. So 4, 8, 12. The Earth's approximate diameter is 12,000 kilometers. All right, moving on. We have stacked bar graphs. Stacked bar graphs are a great way to visualize your data so that you can have one category having 3 subcategories or multiple subcategories. Here I have the 7th grade has 3 categories of books that the 7th grade read: fiction, nonfiction, and biography. And then that's represented again for the 8th grade and the 9th grade. But that one single bar is showing 3 different categories of things. The height of the bar is the total of all categories. So the total of all categories for 9th grade is 120. It reaches this major grid line right there of 120. And then down here, the little colored boxes, fiction, nonfiction, and biography, this is the legend. And the legend is representing the categories that are identified in the graph. So if I wanted to find out how many nonfiction books were read by 9th grade students, I would begin by looking at the 9th grade bar right here. And there are 120 we have 120 total books. But if I want to find out how many of those books that they read were actually nonfiction, I would want to go 120 minus my fiction books, which is 50. Notice asking that question, how many nonfiction books, we actually have 2 categories they're looking for. They're looking for nonfiction and biography because biography is a nonfiction book too. So we get a total of 80 books. There are other types of bar graphs that are that exist, and these 2 bar graphs appear in the teacher guide. So I wanted to include them here so that you could see what they look like. This one right here, we've moved to percentages down here, and we've also moved from a vertical bar stacked bar chart to a horizontal stacked bar chart. These are horizontal lines. And then this stacked bar chart, this stacked bar chart has each category broken out over each subcategory of book broken out over the entire category of 7th grade. There was one thing I forgot to mention up here. Notice how the scale has changed between vertical bar graphs and horizontal. The scale moves to down there, and you still have your axis titles, major grid lines, minor grid lines. I just wanted to point out that the scale is different, or it appears differently when you turn it to the horizontal. All right, do you see the strong relationship? Do you see the strong relationship between frequency tables in Chapter 8 and stacked bar graphs? So here's a frequency table here is this data right here represented as a frequency table from the Chapter 8. Frequency table. Sorry, it's very sloppy. We have multiple things of data going on, and we have a total down here for all 7th graders, but then we have a total over to the right of all fiction. If you don't remember the stuff about frequency tables, go back to Chapter 8 and look at that lesson. All right, circle graphs use sectors to relate a category to the whole. A sector looks just like a piece of the pie. So that's a sector. And in it, you get the percentage that is represented by that slice of the pie. So the mammals down here have 24%. And then the total, if you have a whole pie, you have 100% of the pie. So all the sectors of the pie need to equal 100%. Now, if you are told that there are 300 animals in the zoo, 300 animals in the zoo, and there are 102 birds, 102 of the 300 animals are birds, and you are asked to get the percent. What is that percent, so that you can represent it in a pie chart? You have to take the number of birds and divide it by the all the animals. Remember this formula from earlier. Percent equals percentage divided by base. That one you just kind of have to commit to memory. That one's very hard for my brain to keep in for some reason, so I have to keep reminding myself. Percent equals percentage divided by base. Stop, Josh. Thank you. So 102 divided by 300 equals about 34%. Or it does equal 34%. So that's the reason we have 34% right there in our pie chart. Example 9.1b shows a pie chart of the composition of burl. I think I'm saying that right. And it has 5% beryllium, 10% aluminum, 31% silicon, and 54% oxygen. Which element is the most abundant in burl? Hopefully you can see that it is clearly the 54% oxygen. If the sample of burl had a mass of 300 grams, by the way, I don't know if I'm saying that word right. I could be totally slaughtering it. But if the sample of burl had a mass of 300 grams, what is the mass of the silicon? If the sample of burl had a mass of 300 grams, what is the mass of silicon? So we have a total sample of 300 grams. And we know the percentage of silicon is 31%. So 31% of burl, 31% of burl is silicon. you have to convert the percentage to decimal. So you get 0.31. Now, of burl, 31% of burl. Well, how much burl do we have? We have 300 grams. So we want to multiply this by 300 grams. And then that will equal my silicone. So this is going to equal 93 grams. So where did I get this statement, 31% of burl is silicon? I looked at the pie chart. 31% of burl is the whole, is silicon. Well, what is my whole? My whole is 300 grams. So 31% of 300 grams will be silicon. If that doesn't make sense, think on it. Sometimes it takes a few minutes. Sometimes it takes a little longer. But you do have to exert some brain power to think on it until all of a sudden it's like a light bulb goes off inside and it just suddenly makes sense. All right, line graphs are the last thing. Yay! Progress in keyboarding. And I've got to be honest with you, I have not even read through this. I just copied it and pasted it onto my screen because the previous had taken so very, very long. So first, let's just talk about some terms. This right here is a broken line graph. It's a broken line graph. The dots are connected with choppy lines, so it's called broken line graph. Right here we have a curved line graph because we have just a nice curve. There's no choppiness to it. And then we have a straight line graph here, and we're very familiar with those from all the linear functions that we've been doing. So the last example is example 9.1, and it's looking at the line graph and analyzing some data from it. During which week did Chelsea have her highest words per minute? Well, Chelsea is the red line. We know that from right here. Chelsea is the red. Sorry, I got something on top of my mouse pad and it's making it hard. So we want to look to the point where Chelsea gets the highest, and it's right here. So that is 45, about 45, am I right? Oh, they're asking what week, sorry. Like I said, I didn't read this one. During which week did Chelsea? So that's right there, that's our highest. Well, that's week 10. In which weeks did Chandler have a higher words per minute, that WPM stands for words per minute, than Chelsea? So in which weeks did Chandler, the blue line, have a higher words per minute than Chelsea? So you want to look for any place the blue line appears higher than Chelsea. You don't have to worry about the numbers at all. Just look at the weeks. Well, at week 1, it's higher. At week 2, it's higher. Week 6, week 7, and week 9. See how easy it is to just look at the visual data and note that and not have to worry about analyzing any numbers or anything. I said 9, but I wrote 10. Sorry about that. And I did not mean to underline 10. My orange dot covered that up, but they actually tied right there. So they're not higher there. Let me erase them. I didn't mean to erase my 10. All right, so not higher at 10, they're tied there. Who had the highest words per minute? That would be at week 9, we get the highest. And who is that? That would be Chandler. Good job, Chandler. He had, they add in the answer how many actual weeks that was. So for week 9, Chandler had 50 words per minute. All right, I think that's it. Nothing more. Yay! Good luck with your work.